Hello, everyone. Good morning or good afternoon, depending on where you are joining us from. My name is Valeria Meneses, and as part of the marketing team at Bosch Building Technologies, I give you the warmest welcome to today's webinar, where we'll be introducing our latest feature for our NEXOSPACE Fire System Explorer, the Detector Self-Test. We are really glad that you decided to join us today on this important launch. Before we begin, a couple of technical considerations. Firstly, you now have access to WebEx translation tool. It is a tool developed by WebEx in which you can activate the real-time captioning for both mobile phones and laptops. It is really easy to use, so you just need to go to the bottom left side of your screen and you can find there the CC icon. You can see there the list of all the languages available for which you can choose from. And then you can also customize the text, whether it is to make it larger or smaller, and also to move it around. We are very interested in you using this tool and giving us your feedback afterwards. So please take the time to answer our survey at the end of the presentation. This webinar is being recorded. Hence, all of the microphones have been muted to ensure good audio quality. You are more than welcome to write your questions during the whole session, and we will try to answer as many as possible at the end of the presentation. We will also make sure to send you the recording and the presentation in the next couple of days. Today's presenters are Stephanie Steudel, a NEXOSPACE Fire System Explorer Product Manager, and also joining us, Sebastian Berg, Senior Product Manager for Fire Detectors. You can contact both of them via the QR code in the screen on their LinkedIn accounts. We will also share their contact details to you on the email in the upcoming days. And now, without further ado, Steffi, Sebastian, welcome. Good morning.
Thank you, Valeria. So welcome also from my side. I hope everybody can now also see my screen.
I confirm.
Thank you, Valeria. So I see that we have a lot of participants today, so I'm also glad here that we have so much interest in this new topic and in our new product launch here for the NEXOSPACE Fire System Explorer Detector Self-Test. So let's jump right into the topic. So what is Detector Self-Test about? So our target was here that we give you, especially as a system integrator, many benefits. So the idea is that we have here a continuous test of the detectors running online, so in our NEXOSPACE Fire System Explorer tool. And the test is 24/7 automated. In addition, we also have the VDS 3860 compliance with the test. So those are great benefits. Before Sebastian will go a bit more here into detail, I think the most important things here are also that you can boost your maintenance efficiency with this new feature. So you really boost your maintenance process, you save time for travel and for, of course, the time you spend on site, and you also can save emissions. And one of the biggest benefit in addition is also that you can have this feature just with the license from NEXOSPACE Fire System Explorer that you have today, and also with the hardware that you have today. So if you're already having a Bosch Avena panel and automatic addressable point detectors, there's no need to do any change in your current installation, so you don't need to do any upgrade or anything else. So these are really the benefits of the new feature. And now I will hand over to Sebastian, who will explain it a bit more in detail.
Yes, so hello everyone. To kick things off also from my side, let's start maybe with a short question. So what do you think, what are the key drivers behind effective maintenance of a fire alarm system? So it could be ensuring its functionality, minimizing downtime, or enabling early detection of issues. Yeah, the answer is quite simple, because it's all of them and even more. So overall, we can say that regular maintenance is crucial for ensuring the effectiveness, reliability, but also, and this is important thing, the compliance of fire alarm systems. So it means while ensuring the safety of persons, of individuals and buildings. And yes, on this slide here, I will now show you the 5 main benefits of our new maintenance concept, considering mainly the point type detectors. Starting with the first one, the increased operational safety and optimization of system availability. So continuous end-to-end checks and smart algorithms means higher system availability. So fewer false alarms and less technician intervention. Second, fewer interruptions to maintenance operations means detector self-testing reduces manual maintenance, leading to fewer disruptions, this saving effort time, and at the end, of course, also costs. Especially important this for buildings with a lot of public traffic, like for example, hotels or hospital. This could be a huge benefit. Next point is the predictive maintenance. This means the early problem identification and solution finding. Of course, on fire alarm systems, there could be some errors occur, but with our 24/7 self-check, we identify issues before errors are reported. So the real-time data let technicians respond immediately to any problems occur. The next point is about the effort for the operator. So there's less effort for the operator to enable the maintenance. With fewer access points for technicians are needed, and this is especially important for hard to reach detection points. And last but not least, it's also the reduction of CO2 emissions. So it means digital maintenance reduces on-site technician visits, making it a more sustainable solution. And it's also worth to mention that the current conducting spray gas tests are not really environmental friendly. And also this could lead to damaging on the plastics. So this is a short overview for you with the first 5 main benefits. And I will hand over back to Steffi to show you a little bit deeper insight on the behavior.
Thank you, Sebastian. So we heard about the overall advantages, but where do we really get the intermediate advantages? So for which installation do we get here the great benefit? So I would like you to focus on, let's say, 3 or 4 different kind of installations where you can benefit most of the new detector self-test. Of course, the first of all, we have the benefit for the difficult to access industrial installations. So probably you have here a detector that is installed on a very high ceiling, and it's very time and cost intensive to test this. So here you can really have the big benefit if you don't need to test it on a regular basis. In addition, of course, Sebastian also mentioned for healthcare facilities where there's a continuous operation ongoing. So you have continuous surgery and patients 24/7. You don't want to interrupt. There's really hard to find a time to test the detectors that fits here well. And in addition, here's also the point that we also have for, I think, the next 2 things here, that it's really hard if there's any delay in detecting a fire. Here we have a big issue. This also suits for data centers and secure installation as well as for critical infrastructure projects. Here, in situation where detecting a fire truly depends on every second, and any delay, such, for example, as due to a malfunctioning detector in a room, has a serious impact on this installation. I think here you get the most out of it, of the new feature. So, but now let's go a bit more into less theoretical things, and I would like to explain you how the new feature is working. So you have here the detector self-test with the test target is to reduce the use of spray gas, as we already mentioned. We have an automatic process, so that means the test is carried out on a continuous base. Automatically, you only need to start it once, and then it's restarted automatically. We have a test period. The test is running for 1 quarter. So after 1 quarter, you can also download here a report of the test results and get all the information, and can also hand it over to your customer if you like to. But what does the test consist of? So we have 3 main functionalities of the test. First of all, we have a cloud connectivity test, we have a sensor function test, and we have a sensor communication test. So for cloud connectivity tests, I think it's quite easy. We have here an algorithm that is testing if the connectivity from the Fire panel to the cloud is working on continuous base. With the algorithm, we allow some minor downtimes in more or less 4 seconds. That can, of course, happen, but normally within this 3 months period of time, the cloud connectivity must be there so that we also do not miss any event from the panel that has been sent. Second one, sensor function test. I think this is something maybe a lot of you are already familiar with that, because we already give the information, but in the remote maintenance page here on the Fire System Explorer. But here the important information is that in the remote maintenance section, we give here the real-time data, and now we do here a test from 3 months ongoing. So we test here optical pass, thermal pass, chemical pass, and the EMC check. Of course, only if this is applicable to the detector that you're using. Also here, we have an algorithm running beyond that. So of course, if you have a pollution, then the sensor is polluted. So there's no possibility to reset it at this moment. But we also check here, for example, for EMC or other things. And the third one is the sensor communication test. So of course, it's also important to have all data available that the sensor is sending to the panel. So there can also be that there's a failed communication from the sensor to the panel, so meaning that the panel is not reaching all of the data. So here we are also checking that this is working as expected. And we have here, and of course, in the best case, that all tests have been okay. And in that case, the detector self-test has been run successfully for all the detectors. And then you see this also in the dashboard. You can download here a report and hand it over to the customer. If one of the tests failed for 1 or more detectors, then the question is, what do we need to do here then in addition? According to the VDS, so that is, of course, mainly valid in Germany, it's only necessary to have 1 out of 4 successful tests per year. So we are testing every quarter, and if you have 1 quarter which was tested successfully, you don't need to do a manual test. But of course, you can do a manual spray gas test. That's if you have no quarter where you have tested 1 detector successfully, then of course you need to do a manual spray gas test. So you need to go on site, and probably there's also a serious issue then here with one of the detector, and probably needs to be replaced. So just have this in mind. One additional thing. Of course, detector self-test gives a lot of benefits. What we cannot reduce completely is an on-site visit, because you still have to do a visual check on-site. Of course, it can be the case that the detector is covered. You cannot see it. You cannot also not test it online. So that's one thing you still have to do. And now let's jump in the functionality here. So here you can see a screenshot of how the new feature is working in our Fire System Explorer. You can see here, this is an example from our internal test and training system. So you can see here the new feature, Detector Self-Test, and you already see that here, for example, we have some color coding. So for one of our system, it's red, so there is something failed during this test. We have for the other one, it's gray. That means the self-test has not been started yet. And for the third one, it's green. That means everything is running smoothly and is okay so far. We go deeper. So if you want to start the detector self-test for the first time, you just have to go here and click on Start Detector Self-Test, and then it's running automatically. You will only have here some information about cloud connectivity, sensor function, or sensor communication if you have a failure. In that case, you will see here the information of the detectors that failed. So here's an example of one failure we had. You can blurt it out, but you can see, for example, that for this detectors, there is an issue on the temperature side. You know that we have threshold limits for temperatures, and this limit has been exceeded. So that means there is a temperature that was not allowed to be used for detectors, and we reached this, and that means for those detectors, the test was failing. So if one of the test period is finalized, as I mentioned before, you get here the self-test history. So you get it, of course, for all of the periods. So you have here listed the reports for each quarter, and you can just see it at one glance which failed and which was done successfully. And you can download this as a PDF. And this is how it looks like. Or maybe it's a bit small, but I think you get the main point here. So you have here all the panels and all the detectors that have been tested listed, and also if the test was successfully or if there was a failure in the test. And here you have just some color coding, some information, how many percentage of the detectors have been tested successfully and how many percentage have failed. So much for detector self-test. I mentioned before that if a detector was really failing, of course, you can also test it manually as you do it today with a simple spray gas test. And just as a reminder, so hopefully a lot of you know this functionality already, that we also have a NEXOSPACE Fire System Explorer. Nevertheless, I want to use here the opportunity to give you also some insights about our walk test feature that is available for the Fire System Explorer. So you have here, can do a one-man revision instead of two-man revision with our walk test feature. So at the moment you have here, if you go in the remote maintenance section, you have the possibility to start the walk test from any LSN module. In the future, we will also have again the possibility to start it on the panel level, but for now it's on the walk test, on the module level. Sorry, you can simply start it. It's important that you start it here, and you of course also have to start the walk test on the panel itself. Then next thing is that you choose the variant of the walk test that you want to do. So do you want to do a sequential walk test? That means only one of the sensors of the detector must be tested successfully. Or do you want to do a simultaneous walk test? That means all sensors have to be tested successfully. So you choose the walk test you want to do, and then the walk test is started. And you can see all the listed detectors here on the left-hand side. And as soon as one of the detectors has been tested successfully, it will move automatically here to the right-hand side. So if you finalized the test of all detectors, then at the end, you will also get here a report that you can download either as PDF or as Excel file. So you can also write in here some comments if you want to. And you will find this here in the service history of the remote maintenance section that you can open, and you find all your reports available. Maybe one thing here at the end of the showcase that I want to highlight again is the difference between our remote maintenance data and the detector self-test. So for the remote maintenance data that we are already showing today, it's important to know that we be showing here more or less real-time data. So you have the information about the MC value of detectors now. You will have the temperature information for now. You will have the pollution information as it is today. It's important that with this, of course, you cannot detect something that happens, for example, during night or when you're not looking at the data, because there can be some failures that affect also the future behavior of the detector. So with the self-test, we do here this continuous analysis, and the algorithm does checking for really those 3 months and is analyzing all of the data. I showed you here, for example, the thing with the temperature. That was too low during nighttime. With just having here the remote maintenance data, you would not have found this out because it was simply not shown here if you just have a look here during the day. In addition, with Detector Self-Test, I also showed you that we're not only testing the parameters of the detector itself, but also the connectivity from the Fire panel to the cloud and the connectivity from the detector to the Fire panel. So those are also two main things that are really important, because otherwise there can be some data loss, etc., and which may affect also here the functionality of the detector. And with this, I will hand over to Sebastian, who will give you some deeper insights in the norms and standards.
Exactly. So, when we talk about maintenance of fire alarm systems, there's an important distinction to make, because on the one hand, we have the product norms, like for example, the detectors, the EN 54.5 or the EN 54.7 as an example, and this defines the technical requirements and testing for the product itself. So means at the end, it defines the what. What is the product all about? The technical characteristics, and this is specified by EN norms for specific products, like for a fire alarm panel, for the smoke detectors, or for the manual call points. But what this does not, the EN norm, it does not cover any maintenance activities. It is harmonized standard, but it does not cover and talk about or give guidance about maintenance activities. And on the other hand, the actual maintenance procedures and intervals are governed by various, often local application guidelines and standards. So these application guidelines are not often harmonized. And like I said, it can differ from country to country or from region to region. And these guidelines define how certified products are assembled in a fire system. This means it's a guidance for the life cycle, and is very often only a recommendation and not mandatory on the EU level. This means also it could be in one country they're using it, and in the other country they don't. So this brings us to the challenge, how self-testing systems can support the maintenance. And on the next slide, I will show you how we at Bosch conduct the self-testing mechanism and how we prove the functionality. So at Bosch, we've aligned our approach with the current VDS guideline, which you can see here on the slide. So it's called the VDS 386T. It's called Self-Test Facilities for Components of Fire Detection Technology. So this guideline is currently only a draft. It's also only available in Germany, but it has been agreed upon with the expert public, and it can be used immediately as a basis for testing and certification. As I said, currently only available in the German language. Therefore, if you don't know these application guideline, I will go with you through it and explain a little bit what is the background and what is this all about. So first, the guideline sets out requirements and test methods for self-testing facilities in fire alarm system and components. Means it could be each and every peripheral of these fire alarm device. It's not only about detectors. The purpose is that self-testing features verify the performance and the environmental condition of individual components. Means the VDS is checking here if the products, let's take the detector as an example, when you conduct the test with the spray gas, if we do it in the way now we proposed to the VDS, they're checking if it's the same quality, and at the end they confirm this if it is the case. Regarding the application, it covers self-testing that can be integrated into existing components, or it can be new components. At Bosch, Steffi mentioned it at the beginning, we decided that we implement in existing products. So in our existing detectors, and I think this is a clear advantage because for our solution, you don't need to buy new hardware. You can use the existing Avenar detectors as an example, and just add these FSE and these features for the NEXOSPACE. The key requirements, so self-testing devices must meet specific standards for the effectiveness, reliability, and the proper logging of test results. And like I mentioned, the testing certification carried out by the VDS is, of course, a guideline, the process for testing and certifying these self-test devices, ensuring that they meet the current VDS standards. And then there's one important point. It's the implementation flexibility. So it's not like explained before for EN norms that there's one standard and every player in the market, every manufacturer need to fulfill exactly this way. For this VDS 3816, the guideline focus on desired outcomes for the self-testing. Means it's about the outcome, and this is not in detail explained how you need to come to this outcome. So this is the positive impact, that the manufacturers have significant freedom how they implement. On the other hand side, you need to have, or it's the challenge that it's not easy to compare solutions of each and every player in the market. Yes, so and to give you the highest level of confidence, we have the dual assurance at our end. So on this slide, you see, like I explained, what I meant with dual assurance. On the one hand side, you have the manufacturer confirmation from our end, and on the other hand side, third party approved. You can see on the right side, this is already our newest VDS certificate for detector, and here you can see directly that it's confirmed by the VDS that we fulfill the VDS 3816. And on the other hand side, you can see a screenshot of our user manual of the Avena Detector 4000. And here we are mentioning in the maintenance chapter that our automatic addressable point detectors are validated to support remote functional testing, including triggering the detector with a test criterion. And this remote capability is valid when using our manufacturer-approved test procedures. And the details you find then in the user manual how to conduct it. So I think this is a really nice approval where you convince customers in the market to go with that solution. However, and this is really important to mention regarding the self-test methods, that they cannot replace the maintenance on site by 100%. So the maintenance on site can be reduced for sure, but it's still essential. The visual inspection, for example, for mounting damages or unobstructed detection area, this still must be performed on site by personnel and in accordance with the regulatory maintenance requirements. But our solution is definitely able to support here all the technicians in the field to have an efficient and better maintenance.
Thank you, Sebastian. And with this, we also want to highlight here, or to sum up the advantages from the Bosch solution. First of all, I think we already mentioned that you have here the investment protection through the compatibility of our solution. That means the solution that we are offering can be seamlessly integrated into our existing Avena fire alarm systems, and it's even not necessary to replace the already installed detectors. So that means that will also significantly reduces modernization costs and also simplifies the implementation itself. Second, we have here the highest reliability through the multi-sensor self-test. I also explained it before. That means that the system automatically tests the functionality of all relevant sensor types, so meaning including optical, thermal, and chemical sensors. And this ensures particularly reliable and comprehensive detection performance. The third advantage is that you have really complete safety with continuous monitoring. So the automatic and permanent self-monitoring of the detectors takes place without any interruption or any offline times. So this ensures the continuous protection around the clock. And in addition to that, we of course also have here the unlimited tests that ensuring reliable performance. That means the system carries out an unlimited number of tests, so fully automatically and permanently, because we just have the permanently supervision of all the detectors. And this guarantees, of course, also consistently and high and reliable performance of detectors over their entire service life. And last but not least, we of course also have the environmental aspect here, the reduction of the CO2 emissions and the flammable liquid. So we have a reduction so that we can reduce the spray gas test or even completely avoid testing with aerosol gases, which is currently necessary for testing the detectors. And now coming more or less a bit to the end of our webinar, I also want to give you an overview about our timeline from the go-to-market. So maybe it's interesting for you where we are right now and what are the plans for the future. So for your information, we started with a new feature already in January this year with our private preview. So we only have here a few numbers of test customers which are testing this feature at the moment. For us to do some smaller improvements and some UX adjustments on the feature to give you the best possible outcome at the end. Our plan is for May, that's in 1 month and some days, to start also the public preview. Public preview means as if you have already an existing NEXOSPACE Fire System Explorer account and you have a license for one or more of your systems, then you can already use this feature. So you only have benefits of using it. You can just start, as I explained before, the Detector Self-Test feature and see what's happening. So you get, if there are any issues occurring, you get a list of all the issues, also during the test period. So if there are any issues during the test period, you have the color coding, so the light will turn red if there's an issue, otherwise it will stay green. And at the end of the 3 months test period, then you can also download, as mentioned before, the report. Why is it called public preview? Because the functionality is still a bit in the beta version, so there can be some adjustments that we will do during this period, but it should, or it is running already stable, but can be that we are doing some minor adjustments here. And the general availability, so when the feature is really in the mode or in the final version available, is planned for autumn this year. So just for your information. And if you're asking now, I even don't have any idea of how can I connect my system to the NEXOSPACE File System Explorer Cloud. Here's also a slide for you how to get started, and because you really need to connect your system, of course, to use this new feature. First of all, you need to purchase a gateway and a corresponding license for your system. Maybe I add here the information. So we are offering at the moment 3 kind of license: small, medium, and large license, depending on your system size. So that once you get your system online, you will also find here the information, which kind of license you require for your system. You integrated here also the link to our product catalog. You can also find here more detailed information about license sizes and about the gateway that is necessary. Next step is that you register in NEXOSPACE File System Explorer. So if you already have one account, so one tenant, you can easily add one of your systems. So this system can be done by yourself. If you don't have an account for NEXOSPACE File System Explorer, please contact your Bosch sales representative, and they will help you with creating a new account for your company. And after that this has been created, you will receive an invitation email, and the admin for this account can easily log in. We use here single key ID, so you also have to create here single key ID, but this is mentioned in the process, so this is quite easy. In addition, you can also find here the link to our handbook and to our networking manual, where everything is described here more in detail. Also, with the connection requirements and so on. And the third step is, of course, that you connect your fire alarm system to NEXOSPACE FSE. So this is the final step here. So you just have to enter your remote ID in your Fire panel and then connect it to the NEXOSPACE platform. And then you can see, or the system pops up automatically here in the platform, and then you're connected. And with this done, you're also able to activate the Detector Self-Test and see all the results. So that was it from our side. I hope you enjoyed the webinar and all the information. And yeah, welcome to the Internet of Fire Alarm Systems. And with this, I will hand over to Valeria.
Thank you both, Steffi, Sebastian. Very informative session. I'm sharing now the screen. You also have here the QR code so that you can go directly to the NEXOSPACE Fire System Explorer website, where you will find this and all of the information that Steffi just mentioned. And now we're also ready to move forward with our Q&A section. Before doing that, I will also share this QR code. Please scan it and give us your quick feedback regarding this session. It is very important to us to know if we are doing it right, if there's something that we can improve. And with that, Sebastian, please, Steffi, you can start with the Q&A. I think we have already some questions on the chat, and we also invite people to write their doubts if they have any other left.
Yes. Okay, so let's start with the first question. So there's one: during the self-test, the functionality of detector is maintained. I mean, in case of real fire detectors working properly. So this was the question, and I think I can answer this with the clear yes. So the self-test is running as long as the detectors are running. Of course, if there's a huge fire and detectors or the peripherals get damaged, of course, then we cannot communicate any data. But as soon or as long as the detector is working properly, then also the self-test is working in that way.
Okay, thank you, Sebastian. So then I will proceed with the next question. What are the system requirements on Fire panel side for using the Detector Self-Test? So we already mentioned that Detector Self-Test is working with all existing Avana panels. In addition, there need to be the firmware version 4.4 or higher. We recommend in best case have 4.6 or higher. So, and if what Sebastian already mentioned, it's possible to have it for all point type detectors.
Yeah, then maybe I will continue with the similar question. Steffi already mentioned it. There was a question regarding is the self-test for all addressable point type detectors? So also our invisible versions, the FAP 420. And I can say here a clear yes. So our self-test is not only for the Avana point type detectors, so for the FAP 425, it's also for the invisible versions, so means for all addressable automatic point type detectors we have in our portfolio. And also, if we will have new detectors in the future, we will directly connect them to the FSE platform.
Okay, then I pick the next one. Can you change the interval from 3 months to 1 month or 1 day? So I think that's a question about the interval of the running test. So at the moment, we have a fixed interval of 3 months. Would be interested here, why do you want to change it? I mean, for 1 day, I mean, it's just monitoring during 1 day. So I don't think that you really have a great benefit if you have a test period of 1 day. So then maybe you can also go here with the remote maintenance data that you have, so the live data. We picked this interval of 3 months due to the VDS 3860 because it was aligned with VDS to do this kind of interval, and also because maybe you know for Germany it's necessary to test detectors 4 times a year, or at least some some of the detectors from an installation. That's why we choose for this interval. But of course, if there are any user requirements with or any requirements due to legal stuff from other countries, please write us here the information why you want to change it, and then we can see, because of course, theoretically it's possible, it's just not implemented.
Okay, taking over the next question here. In the Netherlands, the physical action of the fire protection system to be controlled must be checked, as well of the activation of a remote indicator. Is the operation of the remote indicator also checked? And what about the alarm indicator on the smoke detector itself? So the remote indicator is not directly part of the self-check, but the remote indicator, as it's not, it doesn't belong to any norm, because if the indicator on the smoke detector is triggered, then the remote indicator is directly triggered. So to answer this, remote indicator not part of it, but the indicator on the smoke detector is of course triggered here, and it's also part of it. Because we're doing the function tests, we are performing the function tests of all three sensors at our end, so the optical, thermal, and also the CO. And there's a proof of function of this. And if the detector is working quite well, then of course the LED is flashing, then also the remote indicator works. And if not, then there will be at least an event triggered, so that you can directly see at the FSE if something is working not in the way it should be.
Okay. So I have the next question here. What happens if I exchange a detector during a self-test period? Yeah, for this detector, of course, the self-test will fail for this period, but you have 3 more periods to go. So because we have a new number of the new detectors, so this cannot be replaced one-to-one. And if you exchange a detector, then probably there's also an issue with the detector. Probably it's polluted or there's another issue. So it will fail for this detector during this period, but you can start then the next period with a new detector and have the results done here.
Okay, taking over the next questions. How does the self-test work? What happens inside the detector so you can assure it will work? Yes, this is a good question. I can give you a rough overview. Of course, the detailed explanation about our algorithm, about the technology, I'm not able to talk about this in detail. But maybe explain you on the point type detector, the function tests. So like I said, we are performing the tests of all 3 sensors. If you have any pure O sensor, then of course the optical, but if you're multi-criteria, then we are checking the optical, the thermal, and the CO. And we prove the function of the sensors. And within this time frame, all the sensors, but also EMC checks and communication. So as an example, if you have the monitoring of the optical signal path, means detection of influences on the detection characteristics. So in the unlikely event of a defective electronics, for example, the LED or the photodiode, this is detected immediately by our algorithm, and the optical idle value will then report a message to the FSE, and then the customer will informed, or the technician will directly be informed about that. So this is more or less how it works. So about software, about gathering the data, about important algorithms. So this is the way how we do it, but please be or note that I cannot go deeper inside about explaining the functionality on that.
Yeah, maybe also in this direction, I saw kind of funny question now, but I saw the question before that if it's the self-test failing, if the internet connection is interrupted for 10 seconds. So no, but also, yeah, as Sebastian said, we will not show and talk about all the deep information of the algorithm that is behind. So as we said before, it is aligned with VDS, so it's not failing if you have just a short interruption of your internet connection. That's did that. Then maybe I also pick the next question. Do any brand can connect to this cloud system or just Bosch. So an NEXOSPACE Fire System Explorer is only available for Bosch systems. So we really encourage you to use here our Bosch fire alarm systems so that you have the best possibility to connect here to our cloud. And maybe I take another one. So during the self-test scenario, it will still detect smoke fire within its parameters, right? Correct. So there is no blocking point during the self-test. So there's no interruption of the detection service because, as we said, we are just testing with an algorithm the information that the detector sends, and while testing this in our cloud, so it's not tested on the fire panel or detector, so this is an algorithm running in our cloud. Of course, the detector will be continuously detecting fire, smoke while doing the test.
Good. I think we still have perhaps a couple of questions left, but we unfortunately have run out of time. So if you still have some questions regarding this solution, please contact your local Bosch person, and I'm sure they will be happy to help you. I thank you once again, all of you, for participating. And before you go, I also encourage you to follow us on our social networks, specifically on LinkedIn. You can scan the QR code or just type Bosch Life Safety Systems and you will find us there. And also, please subscribe to our newsletter. You can find out about our next launches, our next webinars, and other important information that we share with all of you. Steffi, Sebastian, thank you very much.
Thank you, Valeria, and
Thank
have a
you.
nice day.
Thank you
Wishing
all
you-
for listening. Have a nice
Wishing
day.
you a very
Bye-bye.
nice day.
Bye-bye.
Goodbye.